Good day, my viewers all over the world. I'm Sir Lumaj. In our class today, I'll be dealing with the subject mathematics. And under mathematics, I would like to talk about number basis. Number basis. So today, I'll be very slow and I want it to be very clear. Reason being that it is not only for students in SS2, SS3. If your child is in JSS1, GSS2 to GSS3, they are going to enjoy number basis. That's why I said I want to make it to be very slow. So we are going to have part one and we're going to have part two of number basis. If you have not subscribed to my channel, do so now, please. Like I told us, lots of things are coming up in this YouTube channel. So, number basis. Let's start. Generally, any number you see in mathematics, I repeat, any number you see in mathematics is written in base 10. If I just write, let's say 20, this 20 you are looking at is in base 10. Can be written like this or like this. All calculations in mathematics are all in base 10, but they will not write the base 10. One is not written. Just know that it is a what in base 10. If I write 14, this 14 you are looking at is a what? Base 10. They can now tell you to convert from base 10 to another base. If I say another base, maybe they say convert to base 2, convert to base 3, convert to base 4. It can be written as FOUR4 TH like this. They can call this one binary. They can just write, let's say 50. Let's say I can write 50 to binary. 50 to binary. It means that convert 50, which is in base 10, to base 2. You can convert from base 2 to, let's say, base 8. You can convert from base 9 to base 4. So, how to do all that is what I want to teach under number basis. So, if your child is in GSS1, ensure that they watch this video. If your cousin is in GSS2 or 3 or SS1, 2, 3, make sure that they watch this number basis because it's going to be very, very clearly explained. So, there are three ways in which you can convert your number basis. Like I said, you can say convert 1 from base, convert from base 10 to other bases. If I say other bases, e.g., I can say base 2, base 3, base 4, and so on and so forth. I can say convert from other bases, convert from other bases. So if I say other bases, I'm talking about conversion from either base 2, base 3, base 4, base 2, base 3, base 4, base 5, and so on and so forth to base 10. I can say, okay, convert from one base to another aside base 10. Mean I convert from one base, e.g., I can say base 2 to another base, let's say base 5, FIVE 5, aside base 10. That's what they're doing in number basis. So I'm going to pick it up one after the other. So let's start from the first one, which is convert from base 10 to other bases. So I'm going to use examples to explain it, because that's the only way you can understand it. Then I will be very glad if you can pick up your textbooks and solve questions. Even if you can solve almost 100 or 200 questions related to number bases, it will be so fantastic. So convert from base 10 to other bases. So if I say base 10 to other bases, I can write convert 57, let's say 57 base 10 to binary. Let's start. Convert 57 to base 10 to binary. If I don't want to write it like this, I can write 57 to base 10 to binary. 57 to base 10 to binary. Very simple. How do we go about this? If you still remember your elementary mathematics when you are still in your primary or okay, that you divide. Put your number here, 57. What are we using? What do you want to convert it to? Binary means what? 2. So you bring your 2 here. Then it should now be 2 goes in 57. 2 goes in 5, that is 1, 17. That is 6. Am I right? Sorry. 2 goes in 17, that is 8. Remainder 1. This is 2. 2 goes in 5, rather 2. This is 28, remainder 1. You come again. 2. Because that's what you are using to divide the number. Then 2 goes in 28. You have 2 goes here, that is 1. In 8, that is 4. Do you have anything remaining? No. Remainder 0. Come again. 2. 2 goes in 14. That is what? 7. Do you have anything remaining? No. So it will be remainder 0. You come again. 2 goes in 7. That is 3. You can see 7. This is 1, 2, 3, 4, 5, 6, 7. 2 goes in 7. That is 1. This is 1, 2, 3. Remainder 1. So you have 3. Remainder 1. Then you now come again. 2 goes in 3 is what? 1. Remainder what? 1. This is where students normally make the mistake. Now you now say 2, another 2 again goes in 1. It's not possible. You now say that is 0. So the one that is left here, you now write it 1. So for us to now get the answer to this, you now draw an arrow up. Meaning that you start writing from here. 1, 1, 1. So it's now the answer is now 1, 2, 3. That is 1, 1, 1, 1, 1, 1, 0, 0, 1, 0, 0, 1. I want to believe that is clear, please. If that is not clear, like I said, after you have written 1, 1, 0, 2, 1, then that's it to base 2, which is very, very simple. Very, very simple and straightforward. Simple and straightforward. If that is not clear, like I told us, go listen to my video over and over, over and over. If you can listen over and over, over and over, you are going to get it. So we have gotten this to be the answer. We can also convert from this base 2 to base 10. That will be the other topic I said, convert from base. This is now conversion of base 10 to base 2. Then from other bases back to base 10. That will be another subtopic. So, but here we are dealing with what? Conversion of base 10 to other bases. So we have given also one to solve. So we have this to be our answer. Simple and straightforward. So let's try another question. Convert. Let's convert 14 to base 10 to um to, let's say, base 4, to base 4. So let's go. First thing, you put your 14 here. This is your 4. So 4 goes in 14. How many 4 can you see in 14? 1, 2, that is what? 3. Remainder what? Remainder 2. Let me repeat it. This is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many 4 can you see in 14? 1, 2, 3, 4. That is 1. 1, 2, 3, 4. That is 2. 1, 2, 3, 4. That is 3. Remainder what? Remainder 2. So that's how we have gotten this. Now 4 in 3 is not possible. So you will put what? 0. Remainder what? What is here? So it will not be this way. That will not be what? 32 to base what? 40 to base 4. To base 4. So simple. So simple. So you have converted from base 10 to base 4. So if I want to convert from here back to this, the same way, that will be the next thing we want to do. So I have done conversion from other bases to, from base 10 to other bases. So let's now go from other bases to base 10. 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 Conversion 2. Convert from other bases to base 10. Example A, let's say I say convert 3, 0, 4, 5 base 8 to base 10. Very simple. That's how they'll give you. Convert 3, 0, 4, 5, which is base 8, to base 10. You can rewrite this as 3, 0, 4, 5 base 8 to base 10. So for us to do this now, just follow me. It's very, very simple. Very, very simple. What you just simply need to do is to number the edge of the number. Look at it. We have 3, 0, 4, 5 to base 8. To convert it to base 10, you now start numbering. This is 0, this is 1, this is 2, and that is what? 3. So for us to solve this now, we now go. Now I've numbered it. You want to convert from other bases to base 8. From other bases to base 8. So like I've done, I have already numbered it as 0, 1, 2, 3. Sorry, those in the higher class, you may be complaining that I'm too slow. Yes, so that everybody can enjoy the class. So this is 0, 1, 2, 3 in increasing order. Increasing order is 0 for 5, 1 for 4, 2 for 0, and 3 for this 3. So you in that order. So now for us to now do this, you now pick the first digit, which is 3. It will be 3 times this subscript, which is 8, will now raise to the power of what is on that digit. 3 is on the digit of what? 3. So it will now be 8 raised to power 3 plus, you're going to sum it, is 0 times, can you see? 0 times the subscript, which is 8, raised to the power of what is on this 0. 8 raised to power 0. Then you now have 4 plus, as you are doing it, as you are doing the operation, you'll be adding it. Now I've done for 3. 3 times 8, which is the subscript, raised to the power, that is the number on top of 3, that will be the power. Then you go to the next one, which is 0. It will now be plus is 0. Everything here will be plus, plus, plus. Plus is 0, the same operation, times subscript to what is on top of the number, 8 raised to the power 2, plus 4 times 8 raised to the power of what is on 4, 1. Then plus 8, sorry, plus 5. 5 is what you have. 5 times 8 raised to power is 0. So by the time you do this, what do you call it, simplification, now you now have 3 times, no, this is 8 raised to power 3. It means 8 times 8 times 8. So what is 8 times 8? That's 64. 64 times 8 again. 8 times 4, that is 32. 8 times 6, 48. Plus 1, that is 51. So we have this, okay, times 3 again. Times 3. You have 3 times 2, 6. 3 times 1, 3. 3 times 5, that's 15. So we have 1,536 for 3 times 8 raised to power 3 plus 0 times 8 raised to power 2. What's 8 raised to power 2? That's 64. Or let me even do it one after the other so that I don't mumble up things. So 3 times 8 raised to power 3 is 512. Plus 0 times 8 raised to power 2, that's 64. Plus 4 times 8 raised to power 1. What is 8 raised to power 1? That is 8. Plus 5 times 8 raised to power 0. If you remember by law of indices, any number that is raised to power 0 is equal to what? 1. So 8 raised to power 0 is equal to what? 1. So we now have 3 times 512. That is 1,536. That's what we got here. Plus 0 times 64. That is what? Is 0. Plus 4 times 8. That is 32. Plus 5 times 1, which is equal to what? 5. You now sum this together. So this 1,536 plus is 0. That will be off. Then we now have 32 plus this, that 37. Plus this, we have 1,536 plus 37. So 6 plus that's 3, 6, 7. So the answer is 1,000. This is 51573 to base what? Base 10. Very simple. To base 10. 1573 to what? Base 10. Another one I want to give us is this. Because students normally make mistakes with this one. But I want us to get it once and for all. Sorry. You can have, let's say we have 1, 1, sorry. You can have 1, 1, 1, 1, 0, 1.0112, yes. Let's say to base 10. If you now look at it, this one has dots. The previous ones I gave us no dots. This is decimal point. We want to convert it to base 10. How do you go about this? The first thing you do, you know, you can rewrite this. Either write this or you write 10. So you want to convert this one back to what you are used to. So for us to label this, is labeling. To label this, you can see once you have dots here, just when I wrote 14 the other time, I may ask you where's the dot of this 14. The dot is always after the number. If you don't see dot in a number, if I write 100, I write 260, I write 280, I may ask you where is the dot of all this number. When you don't see dot in a number, it means the dot is after the number. It's after the number. It's after the number. But if I write 2.60, you can see where the dot is. But when dot is not written in a number, just know that the dot is after the number. So like what we have here, we have 110, 1101. Point, you can see where the dot is. So 3 decimal places, you have 011. So for us to do this now, don't forget, once you have dot after the number, you label this as 0, 1, 2, 3. So when you have dots before the number, this one, basically, notice we already have this to a 0. This one will now be -1, -2, -3. I believe that is very clear. So for us to now simplify this one will now be this number times the subscript, the base, that's what they call subscript. Power is what we call superscript or exponent. So we have 1 times the subscript raised to what is above the 1. That will be the power. So you're going to have 1 times, what is subscript? 2 raised to power 3. 1 times subscript, which is 2, which is the base, raised to the power. Then you had plus 1, the same way, times subscript, which is the base, and is 2, raised to the number on top of the 1, which is 2. That will be the power. Plus is 0 times the base, which is 2, raised to the number on top of is 0. You had plus 1 times raised to the power times the base raised to the power of 0. Then you had plus, it will not be the reverse. That will be 0 times half, because this will be 2 raised to power -1. Let me just put it, because I've already taught us this. If you are finding it confused, go and watch my videos. This is 0 times 2 raised to power -1 plus 1 times 2 raised to power -2 plus 1 times 2 raised to power -3. If you are finding it confusing, please go and read and watch my video on the laws of indices. So then maybe, I don't know, you can read watch that one, calculus also. So we have 1 times 2 raised to power 3 means 2 times 2 times 2, 2 in 3 places. That is what? 8. Plus, or let me simplify it. Let me do it step by step. That will be 1 times 2 raised to power 3 is what? 8. Plus 1 times 2 raised to power 2 is 4. Plus is 0 times 2. Plus 1 times, what's 2 raised to power 0? 1. 1 times 1 plus 0 times anything is 0. Then plus 1 times 2 raised to power means 1 times, I want to re-express this, 2 raised to power 2. Let me re-express this also. So we have plus 1 times 1 over 2 raised to power 3. So we now have 1 times 8, that's 8. 1 times 4, sorry, 1 times 8, that's 8, plus 1 times 4, which is plus 4, plus 0 times 2, that is 0, plus 1 times 1 is 1, plus 0 be off. Okay, let me just put it plus 0, plus 0 plus 1. Let 0 is off, this one is out. But let me still leave it. Okay, no, let me just let it be out. Okay, don't worry. So we have plus 1 times 1 over 2, that's 2 raised to power 2, which is what? 4. Plus 1 times 1, 1 all over 2 raised to power 3, 8. So you can quickly factorize this. Don't forget the above mass. 8 plus 4 plus 0, that is 8 plus 4, that is 12. 12 plus 1, that is 13. We have, where do we have? Okay, this one is from where? Because you have to be very careful here. So we have 12, 8 plus 4, that is 12. 12 plus 1, that is 13. 13. So this other one will not be added to this. It will just be a fraction of this number. Let me just put it this way because it's a product. That dot is a product. I can see it here. It's a product, sorry. It's a product. So it's now 12 to this fraction. You find the LCM of these two. I want to believe this is clear. Or they won't show it. It's a product. So these other parts of the dots will be a fraction, and this one will be the whole number and the fraction. So that you now have, what's the LCM of this? 8. What goes in 8? That's 2. 2 plus 1, that is 3 over 8. So we now have 13 whole number, 3 all over 8. That is the answer. Let me re-express it so that I decided to put this plus so that you can be following. So on a good day, the dots will still be there. And when you see dot means what? Times. Product. Times. So I'm changing it now so that you can see it. Dot is here. This is the dot. So we now have, and that dot means times. It means times. Times. Let me just put it so that it's dot too. For those that are really following, you should know that this dot means times. It means times. Times. It means times. I don't want you to be confused. So it means 13 times whatever you have here. And what we got here is what? 13. Oh, sorry, fraction rather. The dot will be what? This is the dot. This is the dot. So you now follow it to be what? 1 times 8. 8. 1 times 4. 4 plus 0 times 2. That's 0. Plus 1 times 1. This is 1. Then dots that we have. This one would now be the whole number. Why this one will be the what? The fraction. So we now have 1 over 4 plus 1 over 8. That is 2 plus 1 over 8. That's 3 over 8. We now have it to be what? 13 whole number, 3 all over 8. So you can re-express this fraction, then you can have it in your. So this one will now be in base 10. 13 whole number, 3 over 8 in base. 13 over 3 over 8 in base. 3 over 8 in base 10. So this is now the answer. So you can lay your hands in any other